So with that, it's now my great pleasure to introduce our first keynote speaker, Peter Zaitsev. Peter is the CEO and co-founder of Percona. He managed the high-performance group within MySQL until 2006 when he founded Percona. And Peter has a master's degree in computer science and is an expert in database kernels, computer hardware, and application scaling. Please join me in welcoming Peter to the podium.
Thank you, Terry. So today I'm going to talk to you about havability and manageability in the cloud. And why did I pick those specific topics? I believe they're very important trends which are going through their MySQL ecosystem recently. Because of that, there is a lot of innovation, and the landscape is really changing quickly. Now, before I talk about those specific trends, I thought I should talk about two important kind of applications, right, which have their own specific challenges which we come to those topics. And I will call those just large and small, right? Large applications would be applications like Facebook, Google, Twitter, LinkedIn, right? They all have ton of MySQL servers and work at extreme scale. At the same time, there are also small applications which can be run on a single server, something as Percona MySQL performance blog, but those also can be significant, which can be very valuable for a business, creating significant revenue and so on and so forth. Now, when we talk about large applications, these are topics about a lot of interest and excitement. If you look at this conference, there are a lot of talks, majority of the talks by practitioners talking about scaling applications of extreme scale, right? These applications which deal with big data, or as Mark Callaghan coined the term, I think last conference or 2 years back, lots and lots of small data, right? Now, if we look at those large applications, they have to scale according to all dimensions, what I would call. They have to scale reads, they have to scale writes, and they all have to scale because they deal with tremendous amount of data. When you think about havability for those applications, it is always very important. Any large application being down is significant cost, right? It should be avoided. And at the same time, it became even very important because they have everyday component failures. When you have 10,000 servers, it's very likely that one of them will misbehave every single day or even every single hour. And if every of its failures would lead to application malfunction and downtime, we would have very bad experience, right? Those guys often have to implement automation for failure handling, at least for most typical one, as well as often there is a trend now moving to even failure injection, such as famous Chow's Monkey project on Netflix, which essentially inject failure to ensure the systems are ready to handle a failure when real trouble comes. We also see for those kind of application increasing amount of hybrid deployments when they not only use MySQL, but some other technologies as well. They can use Memcache for caching, Redis, MongoDB, Cassandra, Hadoop, all together. And I think that is this amazing open source mentality which you have here about using the right tools for the right job. When it comes to the cloud, we see those kind of application making different choices. Some part of their infrastructure may be deployed on a bare metal, which allows them to get best performance. And some can be deployed in the cloud, which offers different advantages of dynamic scaling, automation, and manageability. And those guys working on extreme scale, they have to solve hard problems. They are pushing the boundaries, right, and have to deal with the hardest problem before the fact. And at the scale, everything is harder. It's harder to manage systems, manage performance, and even manage people working on those systems. When it comes to the team specifically, in those applications, we typically have teams of experts which are responsible for those respectful technologies. But at the same time, we see the number of servers, the complexity of the systems, the transaction volume which those systems have to handle grows much faster than a team which is responsible for them, right? So they don't have the leisure time, right, to relax. Efficiency also can be very important for those applications. If you think about that, if you have 10,000 servers running or 100,000 servers running certain workload, getting 10% extra performance and getting rid of 10% of them will be significant cost savings, right? So the larger scale you do, the more important it is to squeeze those few percent for you. And that, I think, is especially important for some applications which have a high proportion of their business costs reflected to infrastructure. When I speak about certain banks, right, or some guys from Wall Street, they can be paying tons of money for Oracle licenses, right, or even run some very expensive mainframes out there because they have a relatively limited transaction volume which support a lot of business revenue. When they are looking at the other kind of applications such as Facebook or WhatsApp, they have to have a really, really efficient infrastructures to be able to process a lot of data at a very low cost. Now let's talk about the small applications. And by small, I call the applications which you could, in theory, run on a single server. And those applications don't really get a lot of media attention, right? Did you have any talks here at the conference about somebody running their home DVD collection successfully with MySQL? Did anybody attend any of those? Well, I don't see a lot of media coverage for those either. But I believe it is same as when we look at the economy in general, right? Small businesses are responsible for large amount of GDP, large amount of economic activities and jobs. Same happens with MySQL applications. There are a lot of them, right? I mean, if you guys can raise your hand, do you have any small applications with MySQL in your company? You see, almost everybody has those, right? And I can tell what, if you think about Percona, and we're a pretty small company, right, by all sides. We have 10 or maybe even 20, I didn't quite count, distinct MySQL-powered applications at Percona. All right. So the trend with those is really single company may have a lot of distinct MySQL-powered applications, and often they're managed by what I would call a zero DBA teams. You often have a zero DBAs for many MySQL applications with system administrators or application developers responsible for managing those applications. Often with the help of some third parties. That could be your managed hosting provider. That could be some sort of web shop which did the website design for you, right? That could be the companies like Percona, which you introduced to be part of your team. In terms of deployment trend, we see a lot of desire for consolidation, virtualization. These applications are small, and it would be waste of time or waste of money to use the big, powerful servers, right, for each and every of them. So this is where virtualization is very important. Same as cloud, which provide us lower cost for those kind of applications because you don't have to have experience in the team to rack the servers, right, or install software, hassle-free and on demand. It is across those kind of applications where new kinds of cloud, where the full package deployment exists, right, is getting very popular, such as OpenShift, Heroku, or automation with Juju. Now, it's interesting to think about the availability when it comes to small applications. The small application doesn't mean low-value application, and it doesn't mean the high availability is not important. Some applications, we may not really care a lot if they're down a little bit, but for others, where high availability can be business critical, because small application may be core part of your business. Now we are talking about now those applications, they often have relatively simple problems, right? These are not the giant applications really push MySQL to its boundaries. Often they run relatively standard MySQL components like WordPress, Drupal, but because those applications often not managed by the dedicated DBAs, right, but experts in other fields, those relatively simple problems by our measures can be hard for them to solve. And that means there is a great potential for having tools which can detect and resolve those problems automatically. So let's switch and talk what's happening in the cloud. Now, the cloud is a wonderful, what I will call, enabling technology. It really helps us with better automation, be more agile, and also efficient for applications. When it comes to MySQL in the cloud, we have essentially two development modes those days. Database as a service, when we use systems like Trove or Amazon RDS, right, with providing us database functionality directly, or we can use cloud just an infrastructure as a service, as an EC2, where we can put our MySQL, selected MySQL server on them. And essentially, database service variants are more easier to use for us, while infrastructure as a service gives us a lot more flexibility, because we can put anything we want in the cloud this way and configure it in the way we want. Now, when we look at the database as a service, it's amazing to see how much choice there is out there. And we are getting more and more database as a service choices from variety of cloud providers these days. So this is a very growing trend. I also believe that OpenStack momentum is very important trend in the cloud those days. And Boris, talking after me, will go in a lot more details about what is happening for OpenStack specifically. Now, I would mention just a few things. In terms of OpenStack, I believe it's very important for MySQL ecosystem because it's open. It will provide us with truly open source cloud infrastructure and vendor neutral. There is a lot of interest from MySQL community for OpenStack, as we saw at our OpenStack Today on Monday at our Open Source Appreciation Day, and in general on this coverage with number of talks and the keynotes and buffs which have been well attended and getting a lot of interest. There are a lot of what I will call core technologies in MySQL which are getting better in the cloud. When you look at the MySQL cluster, it is getting a lot better for mainstream use those days, getting kind of away from this niche database for telecom providers and getting better to service general workloads. With MySQL 5.6, we're getting more robust and reliable replication, which is very important for a cloud. We also have a new generation of high availability technologies, such as Percona XRDB cluster, which was designed thinking a lot about the cloud to begin with, which works well with automatic provisioning, geographical distribution, and which has relatively modest network demand, so it can work well in the cloud. And I think it's also very interesting to see the Oracle working on the MySQL Fabric technology, which should make sharding a lot easier in MySQL, allowing us to really deploy it in this cloud fashion, spreading the workload on a lot of not so powerful instances instead of using a lot of big iron hardware. We're also seeing increased support for management tools for a cloud. If you look at a lot of very commonly used management tools, they all have added support for cloud-based deployment over the years, both in database as a service as well as infrastructure as a service modes. Now, when you think about Percona, observing many customers deploying MySQL in the cloud, their big lesson for us is what cloud reduces amount of people you need to deal with MySQL, but doesn't eliminate that. Even if you have chosen to run your MySQL infrastructure on something as Amazon RDS, you still need somebody to take care of designing the database for you, right? For example, or dealing with some queries that haven't been optimal. Database as a service system do not take care of those things themselves. That also means even if you have to have more people, you have to have less people, these have to often be more experienced people, right? More highly skilled, because their job, instead of some mundane operations like, oh, let me repoint the slave from one master to another, they have to do now high-level activities like schema design, right, or query optimizations, which are harder to automate. I believe for MySQL, the future at MySQL is very bright because of a lot of trends. We are seeing a lot of increase in the affordability, pushing cloud costs lower. Just this week and a few last weeks, there have been major price cuts announcements, both from Amazon and Google, and those happen at least every year, often more frequently than that. Open solutions and the cross-vendor compatibility allowing us to really deploy application either across multiple cloud providers, right, or move from one cloud provider to other puts a lot more competition and pressure to build efficient, scalable, cost-efficient architectures. And as I spoke, MySQL is becoming more friendly for a cloud, which in the end allow us to scale better and easier both for large applications and small ones. So let's now talk about the havability. Now, I think when we talk about havability, we refer to really a little bit more broad set of problems, right? I think it's better not to think about just havability, but about what I will call serverability, right? What do we really need from our application to keep a business door open, right, or avoid introducing some problems for business? And havability alone is not enough here, right? We have to be able to recover backups, for example, because even if you have very highly available cluster, if some developer drops the important table by mistake, you'll have to have a problem with that. We also have to have disaster recovery because we can have a failure for a whole cluster or the whole data center because none of software itself is 100% reliable. And there is also a problem of too much availability, right? Too much availability of a data. When data becomes available for everybody, we have a security problem, right? Then we have to deal with that as well. So what does really limit havability of a system? A lot of focus, I believe, is about the hardware and the platform issues. Things like, oh, my hardware failed, or there is a bug in MySQL and it crashed. But I believe it's responsible only of relatively small part of failures. There is also a lot of issues which can be caused by end-user software bugs, such as you deploy the software which has some very bad query which takes away all resources and takes your system down, as well as operational problems, such as dropping the table in production instead of a test box, right? And then we have to think about those. For operational problems, I would say there are two issues what we may have. One is what I would call the active, right? When we have taken some wrong action, mistakenly drop a wrong table, or get some other mistake, let's say doing MySQL failover, right, or forgetting how much time it may take to alter a table, things like that. And there are also the passive issues. We see a lot of problems come from things like inadequate monitoring when problems are caused by basic preventable things such as running out of disk space. Now, when we speak about the high availability, if you're really pursuing that, you really need to take a broad view and make sure what there's all involved components are covered. You obviously need the software which supports highly available deployments, but you also need your application architecture which can handle that, because in the end, the high availability from a business standpoint is a property of the application, not just the database alone. You also have to invest a lot in testing and training the staff. We see a lot of problems come from people just setting up their software out of a box, don't set in any timeouts or perform any tests, and then, well, guess what? It will fail to fail override, or will have some false positives because haven't been adjusted to your exact environments. You also have to have a proper operations process to have the deployment and the other aspects of operation not causing you those operational problems. And we also have to have tools for monitoring and management which allow us to run those highly available environments effectively. When it comes to software improvements, we also have across-the-board improvements in the software for high availability. MySQL 5.6 and 5.7 have a lot in the replication improvements which allow us to build highly available applications better. MariaDB has a lot of great things going with replication improvements as well. MySQL cluster 5.7, 7.3, my gosh, all those numbers, is getting more, it's increasingly possible to use that cluster technology as a high availability for application. And Percona CEO cluster, well, I mentioned that already. So what do we see in the future in terms of high availability, and what are the trends? Well, we are getting much better MySQL replication, and I believe it will continue to be better in the next years. I believe their database as a service cloud offering will become more robust, and it will be great fit for an increasing number of applications. I also believe we'll see increased adoption of Percona CEO cluster and other Galera-based solutions. Really, we see a lot of traction for those within last year or so because of the advantages for those technologies. And I believe also we'll have much better tools to make the high availability easier than it is now. Now let's talk about the manageability, which I will define as our ability to do more with less. Less people, less skill, and so on and so forth. And this manageability is really important for us to reach our goals, right, with high availability and be successful deploying our application in the cloud. Now, I want to mention some interesting trend in the MySQL market what we observe. I believe we have a high preference to the open source when it comes to core database engine components, right? We can see Oracle themselves, all the core database functionality, storage engine and everything is open source. We have seen companies like TokuDB and InfiniDB went to the open source license in the recent years. At the same time, when it comes to tools and exceptions, these are very accepted by MySQL community, and there are many successful companies in this field. We can see Oracle being very successful with MySQL Enterprise Monitor. TokuDB has TokuDB Enterprise. Several 9 cluster control tool is getting a lot of traction. MariaDB Enterprise is looking to be open core. A set of companies, as I understand, Monjog is proprietary tool. So there is a lot of tools, and this is where their sort of proprietary and open core innovation seems to be happening with MySQL. Now, I also want to talk briefly about our Percona and how we want to help with high availability, manageability in the cloud. We have been investing a lot in the open source manageability. We have been working on Percona toolkit to help DBA with, to automate a lot of their tasks and manage their systems better. We have created a lot of open source solutions for monitoring the database of Percona monitoring plugins. And we also did a lot of extensions in Percona server focused especially on the manageability. At the same time, we are also building up our commercial offerings, specifically with remote DBA, which can help you with a lot of different dimensions. We are working with tens of environments with the customers, and that means we can learn from mistakes, right, essentially on all of them, so amount of the learning with mistakes from your specific environment is a lot less. We also have been building the tools to improve our efficiency, automate things, and by that eliminate mistakes. We also invested a lot in building the proper operational processes, how we handle and escalate alerts, how we make sure we implement proper security for the system, how do we deal with the change management and other aspects of operations. When it comes to our Percona supporter subscription, we have decided to provide our customers with best-of-breed technologies for managing and monitoring applications. We have extended the Mongo with additional Percona advisors, which have been created by our team based on the years of experience of monitoring and managing MySQL. We also are providing Percona cluster control with our Percona cluster support offering, which helps us to manage, deploy, and monitor cloud environments. Now, let me end by stating a few takeaways. Well, first is the MySQL is cloud ready. A lot of people are very successful running MySQL in the cloud right now, today. I believe it is also will become better, right, as all technologies continue to improve. We also see the technologies having us to achieve even higher availability, right, and do that easier. The availability becomes easier and more affordable every year in the MySQL space, which is very important. And also we see the modern tools which are being created and which exist now, which allows our team to be very effective. Finally, let me tell you all thank you for coming to the show and state that we have already have a time scheduled for event next year in April. Or maybe you have some friends in Europe, or maybe you would love to come to the MySQL conference more than once in a year. We would love to see you in London in November. Thank you.